In this problem, what we need to find out is the angle theta for equilibrium. Alright, now if you notice clearly, in this you have CD, right, which is a spring. So if I cut the spring, there will be one force here and one force here. Now in order to find the extension, I need to find out the difference between movement of this and the difference and the moment of this, right? There is also a force acting here equal to P, right? There is this angle theta. Okay, what do we do now? We first take this as the reference. That's the first step. So let's do that. If I take that as a reference and take this distance, okay, to be, let's say, XB, this distance is also the same for this D, XD. Okay, you can easily recognize that, right? Now what happens to XC? XC remains along this particular line, as you can easily see. And therefore this problem is a simple problem to solve. Let's just say the lengths are, instead of taking, so L is equal to 0.15 meters. Okay, now it's possible for me to write, because I have this geometry, right? And therefore if this is L and this is L, I have this total XB is equal to 2 times L cos theta, because this angle is theta, right? Now the active force is P and the spring force, okay, that is between E and D, right? I'm just going to call it as FED. Okay. Since this particular point is not going to move horizontally, all we need to do is to track this particular point XT. Okay, so you can easily recognize that XT is also equal to 2L cos theta. Okay, now there is one more information given over here. It says at 45 degrees the spring is unstretched, right? And therefore if I substitute for 45 degrees, so unstretched position of XT is equal to 2L cos 45 degrees, right? It has moved from this cos 45 degrees to L cos theta. As you can see, this movement is rightward, right? The theta keeps decreasing. Theta decreases, right? So how do we write the problem? Now if we have to write the virtual work principle, we have one that is associated with P, the other associated with FED. So P times delta XB plus, you have this spring force acting like this, which is equal to FED, right? So I'm going to say minus FED times delta XT. There is no other force. This spring force acting here this way is such that the virtual displacement is equal to 0, and therefore does not take place. This is equal to 0. Now it's just a matter of substitution. You can see that XB is equal to this, so I can write delta XB is equal to 2L sin theta minus delta theta. Similarly for XT, delta XT will be minus 2L sin theta delta theta. So as you can see, as delta theta increases, delta XT decreases. we substitute that over here, and it is now possible to find out theta, because what we get here, this is nothing but minus 2l sine theta delta theta, and this is not delta xt. Please remember, this particular force is equal to k times the changed length, which is 2l cos theta, minus the original length, which is 2l cos 45 degrees, times minus 2l sin theta delta theta. Since delta xb and delta xt are the same, we need not find out these quantities at all, because they will cancel each other. All we will get is that P is equal to FED, and therefore P will happen to be K times 2KL times cos theta minus cos 45 degrees. Okay. We can write theta in terms of P and K directly. Did you understand? This is problem 2, tutorial 5, AM 1100 2010 Jan to May. Okay. Thanks, have fun.